Hello, in this video we're going to be talking about this cool thing called the power rule, which is going to make finding derivatives wicked easy. So I've done these off to the side and I found these derivatives, but I'm noticing a pattern here. If I do the derivative of this constant, that's just got a constant slope of 0, so that's just 0. If I check this thing's derivative, that's y equals mx plus b, so the slope has to be 12, so the derivative is also 12. Then this one, I did all the derivative rigmarole, and I got 24, which is very, very similar to this 12 times 2. And then the exponent just dropped by 1. Behold, the power rule, which makes derivatives great. All you got to do in order to find the derivative of something to an exponent is you drop the exponent in front and you subtract 1, and you're done. That's it. It is that easy. Check how cool this is. So this thing, the derivative of that is going to be, if I can find it, it's in here somewhere, is boom, 7x to the 6. You drop that 7, subtract by 1. That is your derivative. In this one, it looks like there's all kinds of things going on, but what we can do is we can convert that into a y equals x to the negative 5, and then we do that same process. Drop that exponent, subtract 1. Negative 5 minus 1 is negative 6. We could clean it up just a touch if we wanted to, if I can find it. It's in here somewhere. Keep seeing it there. Then we get negative 5 over y to the 6th. That's our derivative. So quick and easy. If it's a radical, we can turn that radical into an exponent by making it f of x equals x to the 1/5, and then drop that exponent in front. 1/5 minus 1 is going to be negative 4/5, and then we could rearrange it if we wanted to, but we are done. That is how quick and easy these derivatives are now. Huzzah! Huzzah! In order to do this problem, I want to rewrite it a little bit so I can get that x to a single exponent. So that square root I can write as an x to the 1/2, and then apply my quotient rule of exponents and make this a y equals x to the 1/2 minus 1 is negative 1/2. And then we differentiate that y prime is going to be this exponent in front, which is a negative 1/2, x, and then negative 1/2 minus 1 is negative 3/2. If we wanted to simplify this thing, we can write it as y prime equals 1, and we'll make that negative. And then we got a 2, and then we've got the square root of x to the 3rd. And that is our derivative. In this example, that 6/25 needs to get multiplied by that negative 3 when we bring it in front after we get this exponent out of the denominator. Note that I also cubed that 5 to make it 125. So when we differentiate, y prime ends up being 6 times negative 3 is negative 18 over 125. And we've got x, that negative 3rd gets subtracted by 1, so we get negative 4. So y prime is just negative 18 over 125x to the 4. All right, in this example, we want to find the derivative at a point, but we're still going to use that cool power rule to help us out. So y prime, well, actually, let's just do regular y. So y equals 8x to the negative 2. So that makes y prime to be negative 16, multiply that 8 by the negative 2, x to the negative 3rd. But we don't want just the regular old derivative. We want the derivative at 2, so I just need that x value of 2. So y prime of 2 will be negative 16 times 2 to the negative 3rd, which equals negative 16 over 8, which is negative 2. Now, you might say, hey, wait a minute, what's going on? What about, I don't believe this power rule stuff. No way it's that easy. Well, do you believe your calculator? What if we checked it against your calculator? We can do these on our calculator. Check the link here to see a longer video about how to do it. But what I'm going to do is I'm going to press math, and I want to go to NDeriv, which is the 8th option in my list. So I'm just going to press 8. And then I get this d over dx. Hey, that's derivative. So we're finding derivative with respect to x. And then I can put in the function that I'm trying to find the derivative of, which is 8 over x squared. So 8 over x squared. Oh, not a 2. Squared. There we go. 8 over x squared. And then it's asking me, where do you want to find your derivative at? We want to find it at 2. So I can put in 2, and then bada bing, bada boom, bada, -2. It is a calculator and has to do some weird rigmaroles in order to be able to do this derivative stuff. So that's why it's got a bunch of decimals at the end. But it is -2. Let's try this n-deriv feature one more time. I'm going to do it with a more complicated one with two things. What's going to happen if you've got two things being added together and you want to find the derivative? I bet it's complicated. No, it's not. So I'm going to go n-deriv. It is my 8th option. So I would like to find the derivative with respect to x. So I'm going to put x in that denominator. I'm going to put in my function 2x to the power of 4 minus 3. I would like to find my derivative at the x value of 1. I want the x value of 1. And I put that in, and I get 8. It is apparently 8 for my answer. Well, let's see what happens if we do the power rule stuff on it. Well, what I'm thinking about is if I drop that 4 and multiply it by that 2, that's an 8. So if I do the power rule on that first one, I get 8x to the third, and then I kind of don't need that 3. So I think if we do the derivative, and I actually know, but when I do the derivative and there's things being added and subtracted together, you can just find the derivative of the individual bits. No problem. So this is minus 0. So then when we're finding y prime of 1, you can just plug in that 1. So we get that same 8 that we got on their calculator. So here you can see, yep, I am doing that thing that I said, that if you have the derivative of things being added and subtracted together, you can just find the derivative of the first thing plus or minus whatever this happens to be the derivative of the second thing. So right here, I found the derivative of x, it's 1. And I found the derivative of 11, it's 0, so nothing there. The derivative of x squared is 2x. The derivative of this is 4 times 3, 12. 3 minus 1, 2. Down here, if we want to find f prime of t, that is -3 times 2, which is -6 t. 2 minus 1 is 1, so I'm just going to leave it -6t. Plus, the t with a 2 is just going to be a 2, because that 1 on the t will get multiplied by that 2, and that's still 2. And then we get a t to the 0, but that's silly because that's 1. And then with the 4, we just get a 0. If you find the derivative of a constant, it is 0. So f prime of t is just -6t plus 2. Watch how fast I can do this. S prime of t equals 3t squared plus 10t minus 3. Done! Derivative! That used to take us 20 minutes. Now it's just done and finished. In this example, I've got all kinds of stuff all over the place. I really want to break this up so that I've got two functions being added together. Right now, I've got two functions being added and then divided. So let's distribute that division and make this instead f of x equals 4x cubed over x plus 3x squared over x. That will allow us to find this to be 4x squared plus 3x. Okay, now we can power rule it. So f prime of x, so our derivative, will be 8x plus 3. Finished. In this example, we've got two things being multiplied together. We know how to deal with things being added and subtracted together is what we're talking about right here, not multiplied. So I want to distribute that x in there before I find my derivative. So y would equal x cubed plus x. Now I'm set to do my derivative using the power rule. So y prime will be 3x. 3 minus 2 is 3 minus 1 is 2, and the derivative of x will be just a 1. And there's our derivative. Note that we are using this rule up here. We don't have a rule in this slide for how to find the derivative of things being multiplied together. In this example, we've got we got square root and a cube root. Oh no, this is probably something weird and complicated. No, if we convert those into fractions. So we could write f of x, make these radicals into fractional exponents. This is the square root of x is the same as x to the 1/2 minus a 6x to the 1/3. Now that we have just an exponent there, we can apply our power rule. So we get 1/2 x to the negative 1/2 minus 6 divided by 3, because we got to multiply that 6 and the 1/3, x. 1/3 minus 1 is going to get us negative 2/3 when you get common denominators between those two things. That is our derivative of f of x. Now, we're not in the simplification game, but say we were, because it was a multiple choice problem, we could rewrite this as f prime of x equals 1/2 square root of x minus, let's see, we got 2, 6 divided by 3, and then the cube root of x squared. Huzzah! Hopefully now you see the value of this power rule. It makes finding derivatives so much easier, so much easier. So use it. It is great. We also have these cool properties that we're kind of using just to kind of have more experience with the power rule. But the big deal of the day is this power rule. Thanks for watching. Goodbye.